From the beginning of time, the sun has been the life giver. We have worshipped it in the past, and for centuries we've strived to understand its workings. This amazing solar observatory was built in Jaipur, India, by the 18th century Maharaja Jai Singh. It looks more like a garden of modern sculpture than tools of great precision, but this array of some 30 instruments was designed for a single purpose: to calculate the motions of the sun and stars. One of the instruments is a sundial so accurate that it measures time in seconds. But keeping time, no matter how accurately, tells us little about the sun. Science has been forced to work harder for that knowledge. In that quest, we have read messages in the rock that have unveiled secrets about the behavior of the sun millions of years ago, and we have viewed it anew from space. The newest technologies have captured the beauty of the aurora and helped us to understand the invisible power that connects the sun and planet Earth. Still, the journey is only just beginning, and the unknown awaits discovery. Seen with the naked eye, the sun is a vision of timeless perfection. Telescopes have brought us closer to its surface and taught us it is a dynamic star. But how could we hope to understand the composition of the sun? Beyond human vision, a single beam of sunlight contains a wealth of information about the sun. In the 17th century, the great physicist Sir Isaac Newton performed a simple yet elegant experiment to reveal the message in a beam of light. When sunlight is passed through a prism, it creates a rainbow of colors called the spectrum. What puzzled Newton was the nature of the spectrum. Was the image produced by the glass, or was it contained in the light itself? If the prism creates the color, a second prism should create still another spectrum. Newton found that light through the second prism stayed red. The individual colors of the spectrum could be separated no further. Newton's experiment would prove that white light contains all the colors of the rainbow. Light would become a tool for unlocking the secrets of the universe and form the basis of the modern spectrograph. Like a prism, a spectrograph separates each color of the visible spectrum. Seen in detail, hundreds of black lines appear in distinctive patterns. They are the chemical fingerprint of elements like hydrogen and helium, elements present in the sun. Called Fraunhofer lines, they would open a new frontier of solar exploration by revealing the composition, temperature, and density of the sun. Ultimately, we would learn that the solar spectrum also includes powerful waves of invisible energy: radio, infrared, ultraviolet, X-rays, gamma rays, and cosmic rays. Most are blocked by the filtering effects of the Earth's atmosphere. In 1973, American scientists launched the most powerful array of solar telescopes ever carried into space. Above Earth's atmosphere, Skylab would virtually peel away the sun's invisible layers to photograph its remarkable features. Enhanced by computer, subtle details become vivid images of high temperatures and magnetic turbulence associated with violent activity. An artificial eclipse reveals the intricate architecture of the sun's corona. Ultraviolet and X-ray telescopes record the eruption of a solar prominence and dissect it layer by layer. Skylab would capture details of the sun never seen before, images that would propel a search for the source of the sun's violent activity. It is one of the most hostile environments on Earth. A perpetual desert of snow where temperatures dip 100 degrees below zero. But for those who study the sun, Antarctica is a virtual paradise. At South Pole Station, summer begins in September. For 6 months, the sun never sets. Solar astronomers have long dreamed of observing the sun 24 hours a day. In 1979, the first solar observatory was established at the South Pole. In this crude-looking housing is all the precision required to track the sun continuously and obtain measurements of subtle changes on the solar surface. The need for continuous observation was brought home dramatically when Robin Stebbins and a team of scientists from the United States made an astounding find. While trying to measure the sun's diameter, they accidentally discovered the sun was quaking, virtually ringing like a bell. Back at Sacramento Peak Observatory in the mountains of New Mexico, Stebbins employs a computer to diagram complex patterns of solar oscillations. Here, red represents parts of the solar surface moving away from us, blue moving closer. In a musical instrument, sound is made by a vibrating part, like the keys of a vibraphone or the strings of a bass. Our ears can distinguish the mellow resonance of wood or the cool ring of steel. Just as the sound an instrument creates tells us something about its composition and structure, the various patterns of solar oscillations will help scientists like Robin Stebbins fine-tune their theories about the interior of the sun. Although scientists are now struggling to fathom the workings of the sun, they know that deep in its core, a thermonuclear furnace continuously fuses hydrogen into helium to yield a seemingly inexhaustible supply of energy. Moving outward from the core, densely packed atoms collide and release energy that is radiated toward the surface. Near the surface, gases from the interior are reheated and transported by convection to the photosphere, the visible face of the sun. Here it displays its most spectacular phenomena. Above lies the chromosphere and the corona. Larger than the sun itself, the corona stretches thousands of miles above the surface. Here the sun boils away its outer layer and spews it into space. Far from empty, the region between the sun and Earth is filled with star stuff, fragments of the sun itself, charged particles called plasma. It is the lifeblood of the universe, the most common form of matter. Plasma flows through interplanetary space at 1,000,000 miles an hour to become the solar wind. The discovery of the solar wind would prove a vital link between the sun and planet Earth. Perched high on a mountaintop on the Papago Indian Reservation in Arizona, Kitt Peak Observatory is host to scientists from around the world. Today, researchers from West Germany, Great Britain, and the United States will attempt to create and photograph the world's first artificial comet to learn more about the solar wind. Gerhard Herrendell of West Germany's Max Planck Institute heads the effort. In a few hours, he will order the release of 2 canisters of barium from a satellite orbiting 70,000 miles above the Earth. His objective is to simulate what happens when plasma from a hot star, like the sun, hits a cold object like the Earth.
The experiment, which we hopefully will see if the sky will be clear on the morning of Christmas Day, is the very first in its kind. we have started to develop this technique of throwing a dye into a cosmic plasma already 20 years ago, but we have never had the opportunity to get out of the Earth's magnetic field way into the solar wind, and also to fly it on this experiment on a spacecraft which is equipped with a lot of detectors.
30 years ago, space was considered a vacuum, except for a curious clue, the tail of a comet. Regardless of the direction it traveled, its tail always pointed away from the sun, a mystery unexplained until the discovery of the solar wind. By late afternoon, clouds obscure Kitt Peak. For the experiment to succeed, Herondel must have 3 observation points to locate the comet in space. He has already lost one. In addition to Kitt Peak, cameras have been set up in New Mexico, Hawaii, and aboard aircraft in Tahiti and California.
So, any change?
Werner?
Ja?
Was hat denn der Franz für eine Bildwiederholzeit?
Listen, Paul, it's extremely important. We have to have a rather reliable prediction from you, because now we would only have you and the Southern Pacific aircraft. There's no other station clear. The Convair 990 did not get off the ground. Did I tell you that? I think so. Without the NASA aircraft, I would be very hesitant. See, if anything goes wrong somewhere, then we lose our triangulation possibility. Okay, Mike? Yeah, we just strapped it. White sands is not really quite clear. Yeah, right. Okay. Well, same to you, Mike. I'm sorry. Good. One day we'll get a winner, okay? Yes. Bye-bye.
2 days later, all the observation points are clear. A specially equipped aircraft from NASA's Ames Research Center in California makes a second attempt to record the comet.
15 seconds. 10 seconds.